Yes. I don't care if we start 20 seconds. Tell me when we're streaming. We're live streaming. Oh, okay. I didn't know. I thought you were going to give me the go move. Whatever. All right, we're live. Welcome to the Philly Azure September meeting. I appreciate everybody coming out. Also appreciate everybody who's joined online. We are, as usual, but not always, streaming on Twitch, Mixer, YouTube Live. And we are also YouTube Live is technically recording it and then post to our YouTube channel. So please check all those out and subscribe. Also, we are telling you this now because you are being recorded and broadcast out. So if you want to be on the internet, you can keep quiet or sit in the back, or you can leave. Either way, I'm not offended. I'm just having to let you know that's going on. So cool with that. The usual stuff here. We have an agenda, our announcements, which covers a few things like upcoming events and articles and stuff I like to point out. And then we have two awesome sessions tonight. AKS, it went GA a few months back, and now we brought out a local AKS expert as well as Kubernetes expert, Jason, to come out and talk about it. And then we have an awesome second session. I think I messed up the title of it, but it's basically a lot about databases, and Cassandra Steve will talk from DataStax, who also is our awesome sponsor, and we appreciate that as well. He brought a couple coworkers with, and they're going to talk about all that. I'll let them do their own intro. I'll just butcher that even more. But either way, it's awesome. So please stay around. The second session for those online will start right at around 7 o'clock Eastern time. First, announcements. We'll talk news, events. Our next monthly meeting, it will be on October 17th. It is going to be a joint meetup with the AWS user group here in Philly, and it is actually going to be in Center City. It's not going to be here in Malvern. We've had a few requests to do an event in Center City. This one kind of just fell into place, and they can host it downtown, so we're just going to join with them. It's going to be a Azure compared with AWS, compared possibly with Google Cloud as well, to give you just a nice overview of the platforms, and then kind of take some questions and like that. So we felt it was a good move to kind of have that kind of outreach and joint meeting. Again, that's October 17th, and it will be downtown. Right now, the meetup site is for theirs. I'll post it on soon. Quick show of hands. Is anyone in the room looking to hire somebody who does Azure work? All right. If you are looking to get hired, you don't have to raise your hand. We're kind of on camera, but you can find the gentleman who raised his hand and talk to them later. Quick Azure news. I point this out every month when I do this. If you're not following the Azure.source from the Azure blog, just check it out. It comes out every Monday. Rob Karen of Microsoft puts it together and kind of collates all the data and gives you a really nice rundown. It's weekly. I also post it every Monday to my LinkedIn account. So if you don't go there, but you see it on LinkedIn, friend me, follow me, whatever, you'll see it as well. This past Monday's big announcement was on Azure Devops. We could do an entire day's worth of stuff when it comes to what this announcement was about, but just please go check it out, go read this, and go look at Azure DevOps. It is a big announcement. You want to talk about DevOps, or you want to talk about yours? I got you right on the slide.
Yeah, so Philly.net, the October 20, when yours are on the 17th, right? Okay, October 25th, I think, is our meeting next month, and that's going to be all about Azure DevOps. So if you want to learn more about that, by all means, show up. And as you can see on the slide up there, we are scheduled to have another code camp in the 16th and 17th of November. And we will be sending out, I sent out an email yesterday sort of announcing, like, save the date. But the registration for that will open in 2 weeks, which will be October 2nd. So on Friday, the 16th, there's full day training in 8 or 9 rooms here. And then Saturday, there are hour 15-minute sessions and 5 different tracks or times. So, most of you in here have probably been to our code camps. Look forward to seeing you again.
So we talked about the joint meetup, we talked about Code Camp, and then lastly, again, we want to mention Tech Bash 2018 is coming up October 2nd to the 5th. So also check that out. We want to support them as well. Again, thank you to DataStax for being our sponsor and our second speaker of the night. Our first session is going to be AKS with Rancher 2.0 by Jason Van Brakel. Second session's already here. That's our info. Come on up. We'll switch as quick as possible.
Helps when you try to plug it into HDMI port and not a USB port. All right. So, full disclosure, my name is Jason Van Brakel. I work for Rancher. Everything you see tonight is a product that my company builds that is completely free. So it's not like a model where it's a pay-to-play type of thing. Everything you see in the Enterprise Edition is the same as the Open Source Edition. We make our money by selling support. So I'm not here to sell you anything. I'm going to show you a cool open source project. If you want to get a hold of me at any time, let's see, Philly Dev Slack, Kubernetes Slack, Rancher Slack, and about a half dozen others. I'm at JVB. So just look for this, or if you want to hit me up on Twitter, I'm at Jason Van Brakel. So I'm online almost 24/7 because I work from home. I am the Philadelphia office. So if you have questions, by all means, reach out. That's part of my job. I also enjoy doing it. I'm not a developer advocate by any stretch, but I do work for the field engineering team, and I work with people all the time who are exploring Kubernetes and exploring Rancher. So no slides for me. Just code, just Kubernetes, just Rancher. So Rancher is a cloud agnostic, provider agnostic management system for provisioning and managing Kubernetes clusters. As I said it, sorry about that. Let me just turn that off. And I've already pre-baked some clusters because I just want to make sure that everything was up and running. And since we have an hour, and I'm going to walk through 3 levels here of Kubernetes management. I'm going to walk through a global level, which is this entire manager, a cluster level, which is an individual Kubernetes cluster, and then a project. Oh, sorry. Wrong screen. Thank you. And so I'll have to do a log out and start here so you see it coming in. There we go. All right. Better? All right. So I'm logging with GitHub, and I just do that so I can point out the authentication. But here I have a number of Kubernetes clusters that have already been provisioned. This one provisioned within Rancher, and these 2 imported, created both in Azure Kubernetes Service and in Google Kubernetes Engine. And you might ask, why am I in Azure Meetup showing multiple providers? Well, the simple thing is, Azure went down a couple weeks ago. It really messed up my week. I was doing a lot of Azure Kubernetes Engine work. I had a lot of Terraform that was running against Azure. And for several days, I just couldn't do anything. Nothing worked. And remember a few months ago when S3 went down, half the internet seemed to disappear or be unavailable or be half working. So, as much as I love Azure, and I was a .NET guy for 15 years before being into the Kubernetes space. Love Azure, love .NET. A multi-cloud strategy or a hybrid cloud strategy, hybrid multi-cloud strategy, is something that your company should think about as you're exploring containers and exploring Kubernetes. Now, Rancher is here just to make a lot of that easier. So I'm going to start at the global level, which is Rancher and all the Ranchery things. The cluster level, which is an individual cluster, and I'll stick around this Azure Kubernetes service here since this is Azure Philly after all. And then I'll dive down to a project. And I'll talk a little bit about some of the Kubernetes paradigms involved on each of the screens, what we're fronting for, how we're making it a bit easier. So let's start at authentication. Out of the box, we talk to a bunch of different authentication services to have for for an end user store, for an IDP. We talked to your Active Directory, number of different LDAP servers, Azure AD, which is a pure IDC model, and GitHub as well. And I like using GitHub because I can take my laptop anywhere and show off the GitHub auth. But mechanically, it's the same for all these others, including ADFS. If you're doing single sign-on with ADFS, it just works. You can see all your users that are inside of your user store in your corporation or in your public GitHub groups, or your single sign-on throughout your multiple tenants that are running on your ADFS server. In this case, it was simple GitHub authorization. In the case of an ADFS or an Active Directory scenario, it's a service account. Oh, and by the way, I like informal. Feel free to ask questions as we go. I'll repeat them for people who are listening online, because I know this is one of those drink from the fire hose sections, because there's a lot here. So clusters. Let's talk clusters. We have clusters in Azure Kubernetes Service, DigitalOcean, GKE. Every cluster, we get to see information about the cluster, CPU, memory, how many pods are being used, and general health. And I bring this in here because if you're running on AKS, you're going to see this. This is because AKS splits out how the control plane works within Kubernetes, but there's an API within Kubernetes that's fundamentally broken right now. It's the component status API. Right now, the special interest group within the community that's in charge of either finishing that or replacing that is deciding to replace it and float that around metric server and around a new way of pulling container status and metrics and nodes. That work's not done yet. So instead of spending their time working on an API they're going to deprecate, they're working on a new API. But that means that providers like AKS report unhealthy controller, manager, and scheduler. Every cloud provider treats it a little bit differently. Some have architectured their services so that this isn't a problem. But actually, I think Microsoft has done a better job of creating a better service, even though the health check failed. But I'll have to say, this is a working cluster, so if you're testing out with this yourself, it will still work. If you're a command line person, we give you kubectl right from in here. And it will work, do command line completion for you, and show you everything going on in your cluster. kubectl, if you're a command line guy like me and you have your tools like kubps1, kubectx, kubns, and you want to use your own command line, we provide the kubectl file as well. You'll notice that you're actually authenticating against the Rancher management server, not against the individual Kubernetes cluster. That's because Kubernetes actually supports service accounts and impersonation. So all of your RBAC for your various clusters will flow through Rancher. It does also mean that if you're an ops team and you're running this, you're going to want backdoors in any of your clusters, just in the worst case scenario where Rancher goes down. Rancher only requires one pathway from Kubernetes servers back to Rancher, and that's TLS 443. So mechanically, we have a cluster agent and a cluster node agent on each of the nodes that is sending information back to Rancher management server. So if I were to actually go into this Kubernetes service here and go into the system project, I would see all the things that we installed on the server or things that were installed ahead of time that are sitting in kube system. So we have Heapster, we have kube proxy, we have metric server running. This is something Microsoft provides. And then we have the Cattle cluster agent, Cattle node agent. Cattle cluster agent is running as a daemon set. In Kubernetes terms, that just means I have one pod of that container on each node. The agent runs is just one for the entire agent. If for some reason the node it was on were to go down, it would just go somewhere else because Kubernetes does that for you. So back to global level. So regardless of how many clusters I have, whether they're behind my firewall, in front of my firewall, I have a single pane of glass. Ones that I work with IaaS providers, so we're using Azure as an IaaS and not using Azure Kubernetes service, I can go right into the cluster, go into the cluster nodes, nodes here, and actually increase nodes on the fly. So actually I'll up a worker node here, and that'll be provisioned by my IaaS provider. This also works for Azure IaaS. And then once that's up and ready to go, it's available to the cluster, visible from within here, and visible from within Kubernetes. In an AKS world, I would have to sign into Azure Portal, go into my Kubernetes cluster, and just scale. Go into the scale tab, add worker nodes, and as soon as those worker nodes were available and calling home into Kubernetes, they would show up here. Now, under the covers, we're using Docker Machine for all these various IaaS providers. The ones that are active are the ones that are turned on out of the box, but it's just Docker Machine. So if there's a Docker Machine driver for it, we can ingest it and work with an IaaS provider to spin up your nodes and Docker in a way that works well for Kubernetes. Catalogs, we also have Helm support. So back in January, I did a talk at Philly.net on Helm and Draft. Helm is a Docker hub for distributed systems like Kubernetes, Mesosphere, and Docker Swarm. We give you the ability to have your own private catalogs for that fit the Helm format. Or we'll turn on our library of curated items, as well as Helm Stable and Helm Incubator, which are community efforts. But just think of that as Docker hub for Kubernetes. Full user management. So I already have some users here. I've been working with this cluster all week. These are just various GitHub users, as well as myself. I'm the default admin here. So this is the local user account. That if I were to look at this local user in our API, for example, this local user has both a local account and my GitHub user. All that to say, everything within Rancher is API driven. So it's all HTTP API, which means everything the UI can do, you could do from your CI/CD system. So spin up clusters via automation, spin up users via automation, spin up applications via automation, all with the same automation regardless of cloud provider, whether that be Google, whether it be Amazon, whether it be Azure, or something behind your firewall. Any operation can be navigated. I could create a user right now here from the API, fill in the blanks, hit show request, and I'll get a curl command line and a sample HTTP request. The system supports API tokens. When I create an API key, it's created the same RBAC that I have. I'll skip settings because that's just behind the scenes stuff that's rather boring. I will mention one thing in settings though. Where is it? Don't change this. Don't change the server URL. It'll let you edit it, but it's a bug and it doesn't work well, and then you have lots of pain. So don't do it. You know how I figured that out? I did it. On a POC site, it was not a good day. So we support pod security policies. This is a Kubernetes API that affects what the pod can do and can't do inside. For those that aren't familiar with Kubernetes, inside and out pod is just where your containers live inside of Kubernetes. So all the containers that live in a pod are on the same physical node. They share a local host, a network namespace, and a file system. So it would be as if they were on the same virtual machine. Think of it that way. Pod security policy says what the pod can do when affecting the operating system. Can it mount host paths? Can it escalate to root? Is it a privileged container that is allowed to talk to Docker directly? All these different things. And then if you're a Linux person, you're for Linux capabilities or seccomp filters or AppArmor, SE Linux, these are all things that can be adjusted from within this pod security policy. It gives you very fine-grained control of what service accounts can do, what kind of volumes they can mount, and how the pods and containers can run when they're running within your infrastructure. And it's a way to protect your infrastructure from pods doing things they're not supposed to do. We talked authentication. Now, I spent 3 years doing vanilla Kubernetes prior to my working with Rancher. This is the hallelujah feature. Kubernetes RBAC is a pain. Not because it's not powerful, not because it can't do everything you need it to do, but because it's very, 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 very fine-grained. So generally, it would require having YAML files that you're then managing across multiple clusters, and then when users have different access across multiple clusters, that makes it even harder. Because now you're managing RBAC against service account or username password across multiple clusters, and trying to manage that via some sort of automation and hoping you don't shoot yourself in the foot or give out too much access. So we, out of the box, will put in a user base, various users, and managing some of the top-level Rancher objects. Then at the cluster level, we create concepts called cluster member, cluster owner, these various roles. And then at the project level, so project is our paradigm. In Kubernetes, you isolate RBAC via namespaces. from a user perspective, being within a namespaces, being within a Kubernetes cluster, having your specific set of RBAC. We can group one to many with a project and give out roles in those projects as well. But if I were to click on any one of these, like let's say project owner, which is a very powerful role, you'll see this is what managing Kubernetes RBAC by hand looks like. I have to have a YAML file that defines each individual resource and the set of verbs that are allowed to act upon that resource. You can see how that could be painful across multiple clusters. So it's still painful here. I still have to go through and make fine-grained checks for when it's been custom outside of our suggestions. It's still relatively painful, but also very powerful. And you'll see, if you are a Kubernetes person, you'll notice some things in here that are not Kubernetes, like project loggings, for example. These are our APIs. So we define our APIs on top of Kubernetes using a Kubernetes API called a custom resource definition. So custom resource definition is essentially how you add custom APIs into Kubernetes so you can do Kubernetes RBAC and all the Kubernetes things against them. I've already thrown a lot at you, I can see that. Questions so far? Shoot. So so the question was, do I always have to run it inside the cloud, or can it be behind a closed system? So even an air gap model, for example. Yeah, absolutely. We provide, so this specific cluster is consistent with our documentation, which is called a single node rancher cluster. So mymanagementcluster.com is a domain name that I own that's pointing to right now a DigitalOcean node that is running Docker and then just this container. But if I do HA Rancher, it's inside of Kubernetes. But if I were to go to installation and go to single node install, this is what I'm actually running right now, is this single node install. We have quick start guides, get up and running in a couple of minutes. And then we also have installation for air gap. So we'll give you the list of all the containers that you need to bring in from the outside world prior to running, that you can run through your security scans and run through your checkers so that it's safe inside of your infrastructure. So you could run private Docker registry, private Helm chart registry, private everything, air-gapped away from the world. I'm actually working with some various government customers who are doing just that, where the only time they touch the outside world is to download the containers initially, take them over from a flash drive, put them on the server where the registry is, install them in the registry, and that's the only time somebody touches the outside world, and they're scanned before they're used. That way to ensure they have a pure air-gap solution where there is no talking to the outside world. So like I said, as far as ports go, and I don't remember where that is, fortunately we have a nice little search feature. I can go ports and see port requirements. And most of these are Kubernetes related, or if you're using IaaS related. But the only one that the Rancher node needs, let's see, where's my fancy graphic? We've made it actually useful for operations teams with no fancy graphic. So essentially, it's just 443. 443 from the Kubernetes cluster back to the Rancher management server, which is why it's important that this URL is resolvable from the Kubernetes clusters it's managing. So localhost won't work. Don't do that. I did that too when I was learning Rancher. So, okay, go ahead. All right. Yep. Yeah. Sure thing. So the first question was, what does the upgrade path look like? The second question was, where are we persisting on upgrade path? So upgrade path for single node install is change the Docker container that you're pointing to. 99 times out of 100, it just works. We do have a supported upgrade path that's documented and actually requires a backup and then restoring from backup and doing worst case scenario type of stuff. But this specific cluster, I've upgraded from 205 to 208. Every time the release comes out, just changing the version number and it all works. As far as persistence, it's all etcd. So we're using, for those who don't know, etcd is a high-speed key value store started by CoreOS. It's actually the same key value store that Kubernetes uses.
We have a question coming in from Mixer.
Sure.
It says, what CLI options does Rancher give to spin some Kubernetes nodes across various IaaS?
Okay, good question. So underneath the covers of Rancher Management Server is a tool called RKE, or Rancher Kubernetes Engine. RKE uses a specific format. So let me actually go into one of my clusters and I'll do an edit cluster, because an RKE file looks just like if I hit edit as YAML here. So an RKE file has all the definition about the cluster, including which ingress you want, whether you want a monitoring provider, what version of Kubernetes you install. This is vanilla Kubernetes. All this version number says is we're going to provide metric server and nginx ingress controller and SED of a specific version. It's still all vanilla. We're not forking Kubernetes at all. What network provider? We provide Canal, Calico, and Flannel out of the box. You could import a cluster that's running Weave and it works just fine. The same thing goes for container engines. We do need Docker Engine to talk to, but if you want to modify your container D configuration to have gvisor or Kata containers, they'll work just fine as well. And then I can modify my services. But in here in the RKE world, I'll also have a list of all the different nodes. Let me find that. You know, I can go right here. Oh, it was right there looking at, staring me in the face for a snake that bit me. And then with RKE, and I'll just show a sample RKE file real quick. Let's see, example cluster.yaml. So a minimal is a single node that does all three roles, has a user and an address. And then the full example has significantly more options. I can customize my etcd, I can customize my ingress controller, have internal address versus external address, host name override, which is important in Azure. What versions of Docker you'll support, your SSH key path, which private registries you're going to pull from if you want to do a Bastion node or a jump host, the cluster name itself, the Kubernetes version, and then all the images you're using for each individual type. So if you're using custom registry, you might modify this as well. And then you can customize how each service gets run when it starts. Each individual Kubernetes process. And that's RKE. In addition to that, we also have the Rancher CLI, which is a not as full-featured version of the UI, but ties into the same API that the UI does. And it's just younger. So it's one of those things that as it's developed, it will eventually gain parity with the UI as well. So back to the cluster level. As I mentioned, we see nodes. We will put a nice UI on top of storage. I'll actually show this all from the Azure perspective. This will already be filled in for us. So you inherit the different storage classes. A storage class is just an API that gives an administrator the option to provide storage of a specific type. So that could be standard storage, SSD, multi-region, multiple different providers. In this case, I just have two different Azure disk types, but I could do one for Azure Files as well. Or I could do something completely other than Azure. I could do NFS, Ceph, any number of different options. But if I were to add a class here, I have a number of different classes available. I'm going to say this because it should be common sense, but isn't. Amazon EBS disks don't work in Azure. Nor do Google disks. And don't try to use your Azure disks in Google Cloud Engine. It's just not going to work. I say that because somebody tried it and asked me why it didn't work. These provisioners are the ones that are provided with Kubernetes and the ones that we've added. It's like we have Longhorn here, which is distributed block storage. It's not ready for prime time. It's going to be really cool when it's done. I just did an online meetup today with one of the authors of Longhorn, and he gave the demo with a 0.31 version, which already looks really, really good. And then if you're using something like Portworx or Storage OS, Kubernetes, we support them because Kubernetes supports them. But if I wanted to add in Flex Volume or CSI plugin, they work just fine as well. And then persistent volumes. For those who are unaware, a persistent volume is a Google API that allows you to create persistent volumes based on a driver. So in Azure Disk, for example. In this case, I'd be creating persistent volumes by hand. So I'd have to go into Azure, create the Azure Disk by name, and then add the persistent volume, use the Azure Disk plugin, and I'll actually have to name the disk URL. Kind of tedious, don't you think? That's where storage classes come in, because the storage class works with a provisioner. So if you see I have add class in this provisioner, the provisioner's job is to provision storage on the fly based on a driver. There's a component within Kubernetes called the Cloud Controller Manager, and its job is to manage the relationship between Kubernetes and the cloud provider. So it does things like create layer 4 load balancers with public IPs on your behalf, or cloud storage. But the job of the cloud controller manager is to use the various cloud provider APIs to create IaaS, to manage the Kubernetes cluster from their API perspective. So Google, Amazon, Microsoft all have them, but so does vSphere. So if you're heavily invested in vSphere and have a big vSphere footprint, you could set up the vSphere Cloud Controller Manager and create VMDKs on the fly. Oh, that's the one thing I forgot was add cluster. So out of the box, we support GKE, EKS, AKS, all those IaaS providers, plus the ones that were inactive on the node drivers page. And then we can import existing clusters. So the Azure cluster we're looking at tonight, I imported. And we also do custom cluster. So custom cluster assumes that you know how to spin up your own IaaS and your own Docker, and that's it. If you can bring your own IaaS and your own Docker, custom will work. So I can create custom cluster. Use my RBAC to add members. So if I were to, it doesn't just do users, but also does my groups as well. GitHub, AD, all of those. Using user search base, LDAP, all of that. And then my cluster options, you can see here I have my Kubernetes versions we talked about. Our network provider, we support project network isolation. Think multi-tenant clusters, tenant per project. That way all the things that you do for one tenant aren't visible to another tenant, because Kubernetes by default just runs open. So we'll create Calico policies to make sure one project can't talk to another. You can disable enable pod security policy, include metric server, Nginx ingress controller, enforce Docker, and even have your own cloud provider if you see fit. DigitalOcean's coming out with one. It's not ready yet, but it will be soon. And then from here, like I said, all we assume is you have nodes with Docker installed, and you give it the node type. So etcd being our persistent store. These are control plane, Kubernetes processes doing Kubernetesy things, and then worker nodes that will have your workloads on them. Nodes can be multifunction. So I can go in here, and actually I'm going to try to do this right now. I'm going to have to jump into a VPN, into a private terminal, not that one. I want this. I'll bring it over in a second. I'll just find the right one. So I'm going to launch my VPN. Yep. And then I have to authorize with the VPN. Authorize with VPN. Setting up my local link, so all of my internet-y things will drop out. I'm going to copy that real quick while I still can, because for whatever reason, when I'm VPN here, I can't see the internet. When I'm VPN at home, it works just fine, so we'll work around that. But I'm going to open up my vSphere cluster right here. Okay, I'm going to re-authenticate that apparently. Let's just stop and reload. I have my single worker node here, and I think I create a script that will just execute that on my behalf. Let's see, import GKE, nope, that's not the one I want, that's the one I place node pool. No, I didn't create one for that. Well, so we will hopefully be able to just copy and paste this, and it will just work if I can copy and paste, because I don't have a whole lot of screen. Thank you for reloading, that's exactly what I wanted. Let's try that again. And I'm just going to make this a little bit smaller so that I have a little more real estate to work with. Do I have my VMware tools in here? I don't know if I do. Find out in a second. We're going to launch a web console. I'll log in here. Oh. And the question is, can I paste? No, no, no. I don't know if I can paste without my tools. And that thing is way too long, because I think I've probably already lost that screen because I turned on the VPN. Yep, already lost that screen. So, well, I'm not going to worry about it. Essentially what happens is you run that command against the Docker engine. It starts up a process called Rancher Agent. And then depending on which process you need to start up in Kubernetes, etcd, control plane, or worker, it'll start up a series of Hypercube containers. Hypercube is a community container built by the Kubernetes community that has all the various Kubernetes processes inside the container and just launches the one you need based on the arguments that you send in. And then what that would do after attaching, it would end up back in my cluster. But since I'm having weird VPN issues, it's not easy to do, and I don't have a script prepared to do it automatically. That'll be coming in a later demo. I haven't written it yet. So let's just turn off the VPN so we can go back and see the cluster. Yeah, we can close those tabs now. I'm going to reload this. Yes, we know. I'm using self-signed certs because I just haven't bothered to hook up Let's Encrypt yet. So, but now this custom cluster will just hang out here. I'm going to shrink this just a little bit until there's an etcd and a control plane. So once all that smooths up, eventually there'll be an etcd and a control plane, and that makes a Kubernetes cluster. And it will show up right here. I'm just going to delete this and continue on. So cluster level, we talked about storage. We talked about project namespaces. Like I said, the project is a rancher paradigm to group namespaces. We have, by default, we take the default namespace, we stick it in the default project. Default is just the custom thing that comes with Kubernetes when you install it. System, we provide our cattle system, which has our containers in it, and then kube system and kube public, which come with Kubernetes. You could add the cluster level full membership. I can add any members here using both the lists that I have in my IDP, as well as any roles that I created for clusters, for example. We also have nifty tools for alerting, notifiers, logging, and pipeline. I'm going to ignore pipeline as CI/CD. You're probably already using VSTS or Jenkins or some of those lines that works just fine. There's no reason to change. But if for some reason you didn't, we provide a pipelining feature that's built on top of Jenkins. Alerts, we monitor the health of your nodes as well as various Kubernetes services and can send you notifications over anything that understands webhook. So we have, if anybody's using Rocket Chat, it's Slack, but inside of your data center, that works just fine because it understands webhooks. Most of your monitoring systems understand webhook. And then we'll also set up cluster level logging or project level logging. And I'll note this is a fire hose. So everything that's coming from the cluster and standard out and standard error in your Linux world ends up being sent through here. So if you use Splunk, and I love Splunk, I've built Splunk integrations, it's a great system. It also is priced out via the indexed gigabyte per month. So unless you want to name your firstborn, your dog, and your cat all Splunk, find some other way of filtering your data before you put it to Splunk, because it's just going to be it's a fire hose. But we do support Kafka and syslog and Elasticsearch, and this will eventually go away. We try to embed Elasticsearch in there, and it does work, but it just uses up a tremendous amount of resources, and most companies that want to do huge Elasticsearch clusters already know how to build the huge Elasticsearch clusters. So let's actually spin up some containers now. So at this level, we talked about catalogs and Helm catalogs. We front resources for the various things within Kubernetes. We do alerts at this level too, at the project level. So Kubernetes secrets, they're just key value pairs that are base 64 encoded. So minor protection, they're still not encrypted at rest. In etcd, they're still unencrypted unless you are encrypting etcd. So I bring it out there. Secrets are not the answer for secure key value store. Use a different key value store. I like HashiCorp Vault because it'll run anywhere. There's nothing wrong with Azure Key Vault. It works just fine. Registries, that's your Docker registries. So if you're working with a private registry, you want to set it up in here, one that requires authentication for username and password, that's where this would go. Logging, same thing we just looked at the cluster level, but at a project level instead. Config maps, this is where you separate configuration Kubernetes from the underlying containers that are running. So I can use the same container image for dev, QA, prod, pre-prod, and the only difference is a different set of key value pairs. That can either be sent into the container as environment variables or mounted as files. So every key value item would end up being an item inside of the container. I'll actually create a few of these. So let's just go ahead and create a config map. I can't remember if it allows me to do spaces or not, so I'm just not going to make it angry. 1, value 1, we'll just add another one, key 2, value 2. But this could be configuration for, you know, dev versus QA versus prod, key value pairs. And then we have secrets, so we'll create one of those as well. And the difference really is the protection level at the Kubernetes level. You can put restrictions on how secrets get used, who can see them, that sort of thing. And once they're in the system, they're base 64 encoded, so they're not easy to read. Like I said, they're not encrypted at rest unless you turn on etcd encryption, which Kubernetes does support. I think it's an alpha feature right now, so we don't turn it on by default, but it can be used. Secret, and then we'll do secret 1. Value 1 and secret 2 and value 2. Now let's just go ahead. You can see already once it goes in, I can't see it. If I come back in here to edit it, I still can't. I can replace it, but I can't see it. So now let's actually create a small container. We'll deploy. We're just going to do Nginx because it's quick and easy and downloads quickly. For those who are not Linux people, it's like Apache or IIS, except a lot smaller. We support the various different Kubernetes workloads. So this would be a Kubernetes deployment, which controls how upgrades work and defines what containers you're going to use. This is a Kubernetes daemon set. Literally means put one pod with the containers in on every node. Stateful set, so this creates ordered sets of pods that are spun up and spun down in the same order every time, for use with having multiple listeners on one database, things of that nature, where order matters and the underlying persistence matters. So persistent volumes that are attached to stateful sets automatically just don't disappear. Kubernetes has its own ID of cron job, and then job is to run once and then done. So keep trying to run until you succeed, and then don't run again. So we have our image name. So here's all of our information for our deployment. This is where I create a Kubernetes service. Kubernetes service is a virtual IP inside of your Kubernetes cluster that gives access from the outside world or from within the cluster to your pods inside that are running. So you're not exposing nodes and you're not exposing ports and IPs from within your applications. You're actually creating a separate API called a service to do that for you. And inside of Kubernetes, there's a proxy that round robins to every instance of your pod. So I can add a port inside the container. We know Nginx listens on 80. And there are different types of services with Kubernetes. Host port, don't use host port. Unless you absolutely have something legacy that needs to listen on a specific port on the host, don't do that. Because that means that port is now something you have to manage and think about, and which node is it on, and which node is it listening on. So I lose all the benefits of my distributed orchestration model and Kubernetes doing the Kubernetes things for me. Node port is probably what you're going to use if you use L4. Node port reserves one IP address or one port on every worker node in your cluster. So regardless of where your pod lives, on what node it lives on, every worker is listening for this pod's traffic on a specific port, on L4. So regardless of which worker node I hit, it will eventually get to the right place it needs to go. And if I'm using a cloud provider, I have a layer 4 load balancer. And in this case, since we're on Azure, that will actually spin up a public IP and a load balancer on my behalf. That'll be available to the outside world. And then this doesn't work if you don't have a provider, in which case you'll just see events in Kubernetes saying, hey, we're just waiting for this thing to be available to us, and the Cloud Control Manager isn't doing anything for us. And then cluster IP. That's east-west in the cluster. Only available within the cluster. So create a cluster IP here. I can set environment variables, and I can add in variables from source. Like I said, we can add them from secrets, and we can add them from config maps. We can affect which nodes things get scheduled on based on rules. We can do health checks, so readiness versus liveness. One is, hey, my container is up, and the other is, my application inside of my container is listening. That's the only difference between the two. Volumes, again, I can add persistent volumes via a persistent volume claim. So all you need to know is that persistent volumes in Kubernetes are like nodes or CPUs or anything else. It's a resource to be consumed. A persistent volume claim is a is a request for a specific type of resource, usually by storage class. So I'm going to create a persistent volume claim. I can use my default storage class, or I can pick one. So Azure gives me default managed premium. I'm just going to create a default, and I'm going to ask for 2 gigabytes, and I can customize. Some drivers support something, some drivers support the other. We're gonna ask for single node read write and many nodes read only. This is important because if you over ask and then you go back and try to use a persistent volume claim twice on 2 separate nodes, it may just not work, because when it spun up the first time, it wanted single node read write, and you came back and asked the same claim for something else that it wasn't willing to do. We're going to define that. We're just going to mount that inside my claim. And then I can affect scaling upgrade policy. So how my containers upgrade, how my pods upgrade when I change from V1 to V2. Is it a rolling upgrade? Is it 10 spin down, 10 spin up? Is it everything spins down, then everything spins up? It's how you do canary testing and those type of deployments. How long does it take to spin things up, spin things down? Where is it going to spin things up, spin things down? Those are all things that Kubernetes can do, so that you could, change things on the fly and change them in a way that you control, not just V1 straight to V2. I might have 50% V1, 50% V2, and split them up so I can monitor and see how my things work over time. Any questions, Tim? Okay, we can circle back around. Let me launch this. So what's happening right now is that the config map and the secret are being mounted both as files within the file system and being created as environment variables. I think I did that, or did I not do both of those? I can't remember now. I could look. And then once the Azure provisioner spins up the Azure disk, it can then be mounted into this container as well. And that takes a moment. Now we could see how it's doing if we go ahead and duplicate this. I don't want to lose that screen. But if I go into my cluster, and I look at my storage and look at my persistent volumes, I don't have any defined yet. So I'm not sure why I don't have any defined. I would expect this to go faster than that. If I do have a problem, we can at least see why. So let's actually look at what's going on behind the scenes to see if I've defined something wrong or we're having a problem here. So I can do a kubectl. If I were logging to my logging provider, I could go look at my logging provider. All right, here we go. There's our warning. Unbound, failed to provision store class default, invalid access mode, only access mode read one. Oh, look at that. So I gave it an access mode it can't handle, and it told me that it gave me the business. Now the nice thing about Kubernetes is everything inside is a control loop, going from current state to desired state. So if I just modify what I'm asking for, I think it'll eventually catch up. So if I go back into my volumes and I modify this, no, claim. I don't think, maybe I can't modify it here. Nope. All right, we'll remove the volume and create a new one. New persistent volume claim. Volume. We're going to use the default class again. We're going to ask for 2 gigs, and we're going to ask for single node read write because it can only support that. So in the Kubernetes documentation explains what they all can support.
That kind of comes into these questions that we have coming. So I have 3 questions coming in online. The first one is, how is authentication managed by Rancher across various providers?
Mm-hmm.
So maybe that goes into that. The next one is, does Rancher allow having users set up with different levels of privilege or authorization, either read-only or create containers, create, destroy, et cetera, et cetera. So take those 2 and then come back to me for the next one.
Okay, sounds good. So I'm going to go ahead and just create these real quick. We're going to create config map as volume 2, it's fine. And I'll circle back to those auth questions. So we'll upgrade, and I will let that do its thing. While that is doing its thing, RBAC for the different clusters is controlled at this role-based access control level. So I can define global, so Rancher and all Rancher things and all the managed clusters, cluster level, each individual cluster, and then project. So at the cluster and project level, I can create specific RBAC that is Kubernetes RBAC that has different resource and different verbs against the resource that it can do. and that can be that can also be inherited as well. And then for every user against my cluster and multiple clusters, I can go in and go ahead and add a member. So let's add in a member that I know is one of my test accounts. And so for this specific cluster, I can either give them the member role, the owner role, or a custom role that allows them to do specific things, but only those things. So that's essentially, and that works, that could be, I can now, so now on this node, they have managed nodes, but on the other clusters, or in this cluster, they have managed nodes. On the other clusters, they have no access at all.
So that was for this one. Then
Yep.
the first question was, how is it managed across? Is it various providers? I read that as like Azure versus AWS or something like that.
So everything is managed essentially by Rancher. When you're logging into either via kubectl via the CLI, or via the kubeconfig file, you're authenticating against Rancher Management Server, and then that RBAC is proxied via Kubernetes service account impersonation tools to then be enforced on the managed clusters.
And lastly, a question came in: does Rancher self-monitor itself? Meaning, does it check its own background processes? And
It can. So
okay.
I don't have since I'm not running Azure or Rancher in Kubernetes, I don't have it imported here. But if you run Rancher in Kubernetes, you can import the Rancher cluster, the Kubernetes cluster that Rancher is running HA on, into Rancher, and actually and self alert and self notify and do all those things. So yes, absolutely, it can do that. I don't have it doing that, but it can do that. So let's see if this actually created. Oh, yes, and it did create. So from here, I can actually I can add a sidecar. So sidecar is just another container inside the same pod. So if I want to create a BusyBox container or a Swiss Army knife that had various tools that weren't in my original container, like let's say I saw a memory, I was blowing out my memory every once in a while. I had a sidecar to try to look at that over time. But for every container, I can also view the logs. Now this one is not going to show anything because we haven't run anything against it yet. Let's see. Oh, I didn't create any way of talking to it to create logs. So let's edit it. Oh no, yes, IP only. Whoops. So we'll upgrade to version 2. And you can see here, it's going to create the new one and then spin down the old one, which is the default behavior for how we set up deployments. So this is essentially going from V2 to V3 right now. I could go in here and actually hit rollback, and it will change the settings back for me. But while that is doing its thing, well, so what will happen is once that comes up, this one will come down. I'll give it a second, let it do its thing. Any questions from the room? I know, just throwing a ton at you. Good.
Yeah, if you need any filler while things are going on, or you have questions,
yeah.
My question would be, since this went GA, was there anything specific you noticed in the announcements for GA for AKS, or anything specific that's come out since then that you kind of wanted to highlight?
So the advanced networking features, being able to supply your own VNets. You now have the ability to create private VNets with AKS, together, so you can create private Kubernetes clusters within Azure if it's hooked into your, through your VPN and all of that. That was one of the things that our customers noticed, because they're thinking, a lot of them are, big companies want to protect their data, but might be running out on GovCloud, or might be running GovCloud and VPN into their private center, so it can do that now. So I am not sure why this takes so long here, but let it run for a second. Let's just check the events to see if something hasn't gone wrong and I just haven't noticed it yet. So cluster, kubectl, get event. Or it might just be the upgrade process takes a time because it does have to unbound the PVC and then spin it back up. So I'm seeing that was our error from earlier. That was 4 minutes ago. Failed to provision default sort. Did I? That was 4 minutes. Last seen, failed. I'm not sure why it's failing, but it is failing. Unless I didn't adjust my access mode. Let me go check that one more time. Did I not do that right? I must not have done that right. You know what? Let's just create another one. Why not? Our volume. PVC. Give it a short name. Default class 2 gigs. Customize single read only is fine. Environment variables from source, secrets, and config map. Choose a config map. There we go. Volumes. Let's do it. So we already did that volume. That's mount claim. We're going to add a volume. We're going to use a bind mount so we can see inside of the host because this one is not protected by anything. So we'll just look at Etsy. The path on it is Etsy. We'll Etsy mount here so it's not overwriting that. And then we'll add a volume here for our secrets. Choose a secret. And then add another volume for our config map. Choose config map. And launch. Good. 5 minutes. All right. So I'm just going to remove this one since I've put it in a bad state and it is not happy. We'll let this do its thing. But while this, oops, didn't mean to hit that. Oh, yeah, if you find an issue, you can file it right here. It really hit file issue. It opens up the Rancher project in GitHub and starts the file issue. If you want to use our CLI, which does a lot of things that the UI does, but from a CLI, you can download the CLI and experiment with that. Like I said, it's not as full-featured as our UI. It's getting there, and we'll have more features the UI doesn't have. But it's it's lagging behind a little bit from the UI itself. And then we'll go into here and just make sure everything is happy at the moment. Really should just put this in its own namespace so that it wasn't mixed in with everything else. Make that a little bit smaller so I can see that. So this is all 55 seconds. Oh, look at that, provisioning succeeded. So it's still doing its thing, which is good. I'm happy it's doing its thing. Oh, and it's up. So now I have my Nginx server. Oh, this isn't one of those Azure headaches. So there is an issue where when Azure creates the node port, it uses the private IP, and there's a fix for that, and I don't remember what it is off the top of my head. So yeah, other than your private clusters and your IaaS created clusters, this works just fine. But there is an IP host override combination that just malfunctions for some reason in Kubernetes, and I can't remember why that is. I've read the bug report on it. It's been a little while, but let's say you can view logs, but you can also jump into the container as well. So I'm inside the container, and you can see I have my Etsy mount here. So if I do an ls/Etsy mount, I can see everything that's in Etsy on the host node. I have my config mount, and you can see here I have my key 1 key 2. Oops. And there's my value back here because it's a little bit wonky for whatever reason. And then I have my secret. Where is my secret? There it is. So if I go into secret, there my secrets are in plain text, like cat secret 1, or if I go. There it is, value 1. So if I need to do something with TLS cert key inside the container, I can do that. That'd be a good use for a secret. And then my mount is in here, and if I do a DF on that, I can see here that my mount claim is STD and was created with 2 gigs, and this is under the covers. It's an Azure disk. So if I walked in the Azure portal, I'd see the Azure disk. So I've got 2 minutes. Can I answer any questions for you? As I said, everything here is free. We sell support. That's how we make our money and keep the lights on. We have over 10,000 different customers that are non-paying open source community customers, and I'd say 200 or so paying customers across verticals, across different types of organizations, and across clouds and private. If you have any questions, hit me up on Twitter, on any of the Slacks that I'm on, Philly Dev, Philly Dev, Kubernetes, Rancher, however you'd like to get a hold of me, or I'm jvb@rancher.com. Well, thank you all for listening, and I really appreciate it.
Awesome. Thank you again for that. For those of you online and also in the room, we're just going to take a brief second to switch over to our second session. So stay put, and it should be done in just a minute.
Test, test, test. Hey, sounds like it. Let me know when you're ready. Okay. Good evening. My name is Steve Bevilacqua, and I'm with DataStax, which is the Apache Cassandra company. Who here is organizations run Apache Cassandra, if you know? Got one? How familiar you are? Is everybody aware of what Apache Cassandra is? Have you heard of it? So we'll do a little bit of an overview of Cassandra, and then David's going to take us through a demonstration of the database and have a little fun showing you some of the power of what Apache Cassandra can do. So let me start. So most people are running relational SQL databases. So the original thing we're going to talk about is why NoSQL versus SQL. The reality is we're not going to spend a lot of time on that. But when companies are looking to run, why do companies want to switch from SQL to NoSQL? It's generally because they've got really large data volumes, and they've got to be able to handle the velocity, the variety of data, and the volume and complexity. So some of the largest clients in the world are running Cassandra. If you think of Apple, and a couple years back, they reported having 75,000 nodes of Apache Cassandra running. So if you think iMessage, Apple Pay, and those kinds of applications, one of the things you realize with those applications is how often do they go down? When was the last time an iMessage didn't go through? So the applications that run on Cassandra are extremely resilient. It's continuous availability, which you talked about. Data location independence. I'll talk about this a couple times. It's really the only database that was designed from the ground up to be running on-prem, in cloud, across multi-clouds without any additional software. And it's a flexible data model, which is a lot of why people originally moved to it. So you've got structured, semi-structured, and unstructured data within the database. So Apache Cassandra is obviously OSS software. And with the advent of the internet, OSS really took off. About 10 years ago, the volumes were getting so large at companies like Facebook and Amazon, and they had huge scaling problems. So there were a couple technical white papers that were written by both Facebook and Amazon on how to address this. And so Facebook's version was essentially what became Apache Cassandra. And the project took off, and when it was donated to Apache Cassandra, DataStax was actually formed to provide support, similar to the way Rancher was providing support for Kubernetes. DataStax provides support for Apache Cassandra. Now, we've done a lot more to it than that. So we have the basic Apache Cassandra, which we've provided some performance enhancements to. But we've also added integrated Apache Spark for analytics, Apache Solr for search, and we've provided a graph database as well. So you've got the scalability of a graph database in there. So if you look at why companies like Microsoft are so interested in having open source databases, and we're actually going to run our demo on Azure, is because that's where the growth is. If you look at what's happening with paid commercial licenses of software over the last 5 years, they've declined 15%. So clearly the open source licenses, which can be paid or not paid depending upon how you want to run your enterprise, but clearly there's going to be an inflection point there. So there's going to be a lot more revenue and money to be made on the open source side compared to commercial software over time. So one person raised their hand that their organization runs Apache Cassandra. I would contend that there's more run Apache Cassandra than you realize. So there was a survey, and 26% of enterprises in the US actually run Cassandra. Just some of the big players. Netflix is one of the larger clients that run it. If you look at the recommendation engine within Netflix, if you watch a movie, and since you liked an action movie, it'll suggest a few more action movies that you may like. Well, that's all running on Cassandra, and it does 1 trillion transactions a day to make that recommendation to you for that next movie. And the reason why it's so important to Netflix is if you're going to watch that next video, you're less likely to churn as a customer because you're like, oh, I'm continually watching movie after movie within Netflix. So the kind of volume we're talking about is pretty impressive. Two things to walk away from an Apache Cassandra is that it's an active everywhere database. It's a masterless architecture, and it's the only one that's really designed that way. And secondly, and I talked about this earlier, it's a single data fabric for on-prem, hybrid cloud to multi-cloud. So we talked about the masterless architecture. It's really a peer-to-peer. There's a protocol that talks amongst the nodes and basically does a heartbeat amongst them, make sure that they're in a good state. But you basically share the information across multiple nodes. So when you design a Cassandra cluster, you say what your replication factor is going to be. So most people start with at least a replication factor of 3. So you'll have 3 copies of the same data. That can be in the current cluster. It can be in a cluster across the country, across the world. But you spread your data across multiple clusters, and you spread the workload across multiple clusters. So if you've got let's say you've got a failure on node 2 in the cluster, you've only lost 1 out of the 3 copies. So you can continually run and creates 100% uptime. If you end up losing an entire data center, so if you've got an Azure environment, we've got an east-west data center, and you've lost the East Coast one, which happened a few weeks ago, you'll be able to keep running because the data's still going to be available on the West Coast. Any questions on that? The other thing with Cassandra is it's really built to be a scalable database. So every additional node you add to the cluster is going to actually linearly scale the capacity of the cluster, both obviously storage, but more importantly in performance. And finally, so Cassandra is really born to do hybrid cloud. So many of our customers are looking at multi-cloud solutions. So if you look at both running on Azure or one of the other platforms as well as on-prem, essentially the nodes don't have an understanding of that you're running on cloud. Everything is native to what we've designed. If you look at these clients, you may say, what's unique about these companies? They've really all been disruptive in the marketplace. So they've got, Uber, Netflix. They've all changed the game. And then more people running Cassandra is these people really have done a digital transformation within their organizations. It could be around customer experience. It could be around like Sony's done all their online gaming is today run on Apache Cassandra as well. So that was the brief overview. Any questions on Cassandra?
Switch over.
Yeah, must be on the other side.
Turn my mic on. You guys can hear me? Good. All right, let me plug in. Okay, cool. All righty, so I promise I'm not going to bore you guys with too many slides, but I am going to give you some slides. All right, good. You guys are seeing that. So, hello, I'm David Gilardi, also from DataStax, and I'm a developer advocate. So, our team, we're coders, we build apps, we build reference apps against not just Apache Cassandra, but the DataStax stack as well. Our main objective really is to make people awesome with the tech. So, we commit this, other than like a eat your own dog food kind of methodology, if you will, but we kind of come at this as like chaos monkeys inside of DataStax because we're not on development teams, we're not in QA. We test all the stuff, we write apps against it, and if we find things that don't work, or if we get feedback from the folks out in the industry and everything, we're kind of the advocates inside of DataStax. So that's where we come from here. So the demo, and kind of what I want to show you guys today, we're going to get into this app. It's one of our reference apps. It's called Killer Video. It's like YouTube Lite, right? And the reason why I'm telling you about this particular app is this is going to set the context of all of the stuff I'm actually going to show you. Alrighty. So, like I mentioned, YouTube or Killer Video is just like a YouTube Lite. So it's got all the basic types of functionality you might expect with that. It is, by the way, it's a full-fledged app. It's not just a demo, and I lost my screen. There it goes. It's not just a demo. It is a full-fledged microservice-style application. It's got a full stack. I'll show you some of the services here in a moment. And we do that, we build these apps because this is a way that we can, when you're looking at a document page and you see a code snippet, that's one way to kind of learn something. But when you actually see it implemented for real in a real piece of code, that's a whole different way of actually presenting the information. That's where this comes from. So from the app itself, simply enough, with managing user accounts, you could, register a new account. I'm not sure why it's doing that, but we'll see if it keeps doing that. You can register new accounts, you can sign in, there's authentication, such like that there. It is a video sharing service, so you can upload videos from YouTube, you can tag those videos. Once you have some videos in the system, then you can search on those videos. Now, I should mention that some of the things that we're talking about here are going to be powered by some of the various workloads that Steve was mentioning. So all of this is on that Cassandra core, right? But for some of the capabilities, we're actually going to get in. We're going to scratch the surface with search, with graph, right? We're going to look at some of the capabilities, and that's where some of these come into play. And then once you can search a video. Then if you find one you like, you can watch it. That would be weird if you have a video sharing service and you can't actually watch the videos. Then you can comment and rate on videos. And on the right-hand side, what you're seeing there is just a conceptual data model. That is generally the data model that we use that informs how we're creating, whether it's our schema or data model inside of Cassandra, or if it's in Graph or Search or wherever. And some of the key entities there are going to be user, comment, and video, and tags actually as well. You'll see that come up in the searches. All right, so from a really high-level architecture standpoint, right, this is not going to be unfamiliar to anybody in this room. It's essentially just a three-tier structure where you have the web tier is going to be, where someone's coming in and your UI, UX, that's how they're interacting with the app. That is actually in its own set of services with Node.js and Falcor. Then you've got the core of Killer Video. This is where the meat is. This is where all of the business logic is. This is where a lot of the services that I'm talking about exist. Now, the key thing about this, from a learning tool standpoint, it's a reference app. So we have multiple language variants. We support it in Java, C#, and Node.js. And for those of you, if you're C# developers and you're looking to figure out, well, how do I do this? We just released the poor C# version had been neglected for, I don't want to say how long, but it was a long time. And we just released a brand new upgraded version of that has all the new support for graph, search, new drivers, everything. So we do maintain 3 different major language variants, and that's, again, where all of the meat of Killer Video is. And then that's supported, of course, by the DataStax drivers. That's how we're going to talk to the database. And underneath the hood is, in fact, DataStax Enterprise. And as I mentioned, we're talking with Cassandra Search and Graph. We don't have analytics yet implemented from a Killer Video standpoint, but we've got the other 3 pieces. From the deployment part, and why this actually matters, especially from a developer standpoint, right, is that top one. This was always intended to be, again, a tool that people can go and download. It's totally open source. It's free. You grab it. And they can go, well, how do I actually stand up an ecosystem? Like, I want to talk to a Cassandra or a DataStax Enterprise database. I want to see how the code works and all that. That's what that's intended for. So all of this is completely containerized. You can just pull it down. All the services, everything you need, they're there. The secondary one, we're not really going to talk about DataStax Managed Cloud today, but it is an option. As a matter of fact, if you were to go to like dev.killervideo.com, we do have our own deployment that's up on the cloud. And as I was talking before, again, when you're writing an app for a local instance on your laptop, it's completely different compared to when you're actually deployed in multiple data centers, multiple regions in the cloud, having to manage various instances and such. The way that you write the app is going to change. And again, we do that because we want it to be as absolutely real as it could be for folks who are actually doing this. Now today, we're going to deploy on Azure. We're going to use Test Drive, and we're going to deploy a cluster up on Azure, and we're going to put this whole thing together that way. So from the services standpoint, I mentioned it's a microservice style architecture app. So we're not going to go through all these. We don't need to do that. But really what I want to point out is, and this is when I'm talking about this core, you can see on the left-hand side that user management service, right? If you're handling sign-in, registering, authentication, that's a black box, right? That service is totally cordoned off. It's going to handle those things. And it's the same for each of the other services that you see there, right? So they could be, even though I'm running them within the same container, they could actually be separated out and run on their own individually. In the bottom part there, you see those green boxes. Those are just a sampling of some of the tables that are in the database, and each of the services own their own. So like user management service would have things like users, user videos, and so on. Okay, so getting into the data tier. Now we're not going to go too deep into this. I saw one person raise their hand earlier with Steve that actually runs Cassandra, right? I don't know how familiar you guys are. I'm very curious by show of hands with anyone who's actually done anything with a Cassandra database, CQL. Are you familiar there? Okay, I got another one. I know I recognize your face anyway. So if you're coming from the SQL world, right, and you're using a relational database, and then you come into CQL, this should look honestly awfully familiar. There are differences in CQL, there's no doubt, but when you're talking like the basic commands, a lot of the statements that you might use to create a table or even to do some of your queries, it's really, really similar, right? So the piece that you see on there on the right-hand side, that is just a sampling of what you might see to create part of the data model. Here we're just creating a table. So again, from a syntax standpoint, it's not that different. Where it is in fact different, and Steve was talking about this a little bit, is how you go about designing your tables, the actual data model, the queries that you're going to use. From a relational standpoint, you pretty much design your schema to handle kind of any query that could come at you in the future. You have join tables. You don't have that concept in Cassandra, right? So it's more of a query first design approach, where I'm going to design my tables based off of the type of questions my app may ask. Some examples, in the case of Killer Video, you can rate a video. So I may end up with a table that's rate by video, right? And I'm actually going to have a table that's specific to that particular use case. Or maybe I could have another case where I have a tag by video or a comment or something. So I may break up and get it. It's a denormalized pattern compared to what you might do in the relational world. For search, now how many of you guys are familiar with Solr and Lucene? Anyone? Okay, I got a couple more on that one. So This, if you've done it in OSS and open source before, this is a tight integration with the DataStax stack, and it is Solr and Lucene underneath the hood, right? Now, one of the cool things, and I'm going to show you this here in a minute, but one of the cool things we get to do with the search integration is you get direct access through CQL, through the language. It's SQL-like. So when you have search indexes that are enabled in your columns, you can just write queries against those indexes, and it looks just like SQL. And honestly, it looks more like SQL, and I'll show you that. But what's going on here is that all of their various pieces inside of Killer Video that are actually powered by DSC search. So if you see that left-hand box, the type ahead search bar, that stuff, we've been doing type ahead searches for how long, right? Everybody in the industry, that's not new. But that capability, the underlying core piece is search. We have a tag search that you see on the right. There's the more videos like this piece. All those pieces are actually powered by the search aspect of DSC. And then there's graph, right? I don't know, how many of you guys are familiar with graph databases? All right, I got a couple more. All right, so graph is really interesting. It gets into a new paradigm, right? The focus of graph is on the relationship between entities. So you start getting into really interesting use cases. We actually see a ton of people in fraud detection. You get some customer 360 pieces. The piece that we did in Killer Video was a recommendation engine. So you can actually use graph to help tease out some of those relationships that in a general SQL sense could end up with some really hairy nested SQL queries if you were to try to do the same thing. So graph databases are really particular need for this. If you're not familiar with graph, all I really want to point out is if you look at the bottom left-hand side there, that is actually the schema that we're using in Killer Video. It's really simple. And there's two things there. You have vertices and you have edges, right? So the vertices are those boxes. So if you see things like user, video, and tag, those are our vertices. And then you see those lines connecting them, like user rated a video, user uploaded a video, right? Those are those edges that are defining the relationships. And later as we get into it, I'll show you how that starts to emerge and where that comes into play. So if you are someone who is interested in taking a look at this stuff, oh, my screen went out again. Whoa, there we go. If you're interested in taking a look at this stuff, go to killervideo.github.io. That's the starting place. Hit get started, and that will explain, okay, what's Docker? How do I download this stuff? I'm using IntelliJ if I'm in Java and I'm curious to get my ID hooked up. How do I do that? That's where you go. If you want to do anything with code, like I said, it's all open source. That's where github.com/killervideo is. That is the main repo, and under it, you'll notice that there's Killer Video Node.js, Killer Video Java, all sorts of things. All of the services, everything is there, right? And you want to put in a pull request, you got some improvements, totally do it. I'm down. All right, one last thing as far as the slides go. So there is a tour mode. So when you go into Killer Video, you look at the top right-hand corner, you see this little tour. This part, I didn't write this, but I'm really stoked about it. It's actually really cool. What it will do is when you hit the tour mode, it'll bring you through the app, and it will point out what's going on with the data model, provide some resources and such. So it'll start to explain, okay, here's the table here that we used. And by the way, here's the link to some of the documentation to explain how this works. So if you're curious about, well, what part of what workloads are in place for this part of the app, what do they do for this area in the data model? That's where you can use the tour mode. Okay, yes, this part. Yay, live demo. All right, so what I did is I've got a setup here. Now, I mentioned that we're using Docker, and this would be very similar if you did this on your local machine, right? So I've got the full Docker ecosystem, and what we're going to do is we're going to launch that in test drive. Now, I did slightly cheat, and what I mean by that is I launched test drive. You can tell you get a test drive for 3 hours in this particular case, right? So it's been up for about an hour and a half. And the reason why I did that is when it takes about 10-15 minutes to actually bootstrap the cluster, get that all up and going. Then I wanted to actually seed it with enough data from a demo perspective for you guys to see something good. Is part of Killer Video in the services. There's the generator service, and what that does is actually will pull videos from YouTube. It will populate it. It'll add comments, ratings. It makes it look like the site is active. So it's just nice from a standpoint of a way to get data ingested in the system. So it takes about an hour for it to get enough for it to be fun, right? So I just let that run. So I technically already started the test drive and it spun up a cluster. Now what that does is once I've got my cluster running, it's going to provide you with these two links here. So we're going to look at these real fast. If I can only click on that. There we go. All right, so this is Op Center. We're not going to go into real detail about Op Center. I just want to show you it's a thing, and I want to show you the cluster. And we're going to look at some of the items here. So Op Center, it's a part that comes with DataStax Enterprise. It's just there. It is an operations management tool. You can use it to deploy your clusters, to get information on the cluster, and do all sorts of fun things. What I really want to point out here is you see our 3 nodes. So when I started the DSE instance through test drive, it's just a button. It actually generated this 3-node cluster for me. And notice here, we're going to pay attention to our data center. I want you to notice that, and the IP. We'll grab that here in a moment. All right, so what I want to do is now, just want to point something out. So how many of you guys are familiar with Docker Compose? Anyone use that before? Okay, just a couple. So let me explain real quick. So Docker is a containment service or a container service. It allows us to, in a single instance, run, like in our case, we have, funny enough, the last guy had the same thing with etcd. We use etcd as a key value for certain things. We have all of the services in Killer Video. We've got the generator service I mentioned. In the local Docker instance, if you're not hooking up to an external cluster like we are, you have a full DSE stack, everything. So each one of those is run in their own containers within that instance, and they all have, they can share the network. They can all see each other, right? It makes it so much easier to deploy, especially for a test scenario. If I want to test different versions, or I don't want to have to touch 8 different machines and have all the stuff running in different places, it's really good for that. So with Docker, there is also something called Docker Compose. It's really good for a case like what we have, where you have lots of containers, lots of different configuration, maybe different versions. So it makes it easy to get this thing started up and running. So what you see here in our file here, our configuration file, is just, these are environment variables that are going to be passed onto my Docker containers, right? That's all stuff that's set up in my Docker Compose. And what I really want to point out is that you see this IP here. What we're going to do is, yeah, that should be that guy. So 4080, 155, 111. So that's just, it could have been any one of them. It didn't matter. So I'm just telling it, this is a configuration that you can set in Killer Video to talk to an external server. But I'm just telling it, I want you to go there. Now, that data center piece I was talking about, that DC0, something that Steve mentioned, when you actually create your clusters, you have this idea of a replication factor, right? So one of the differences in Cassandra is when you create your key spaces, or your schema, if you will, you're gonna tell it what your replication factor is and what data centers you have, right? In this case, we have 1 data center, and I have 3 nodes, and I actually want to replicate to 3 of them. So that's all I'm doing here. If I had more data centers, or if I wanted a different replication factor, I would just set that at my key space. No big deal. It makes it really easy to replicate out natively. But here, I'm just passing this. Again, I'm just passing this to my Bootstrap. So when we start up the app, it's going to bootstrap. It's going to create all of the data model, everything we need. So, all right, I just want to point that part out. So here comes the fun. So we've got our cluster up. Now what I'm going to do is I'm going to run Docker Compose with a -d, which tells it go into the background, because you don't want all the standard out and stuff coming into the foreground. And Kitomatic is actually a really neat tool that if you have Docker, I don't know about the Windows one, honestly, but the Docker for Mac, it has that there. Here, this is what I want to point out. So here's an example you can see now. Here are the various containers, right? This is in Docker. So I have this DSE config. Now this is the Bootstrap. This guy is responsible for actually creating, this is something we built, by the way. This is just part of Killer Video. So it's actually going and creating my whole data model. So right there, we just created what we needed for Cassandra, all, the key space, the tables, what we needed for our search indexes, and our graph. And what's important is this little guy here, because that will then set my values in etcd. And etcd in this case, it's just storing the way that services in the Killer Video ecosystem know where the cluster is we store that in etcd. We say, hey, guess what? Here's my Cassandra cluster. Here are the IPs. Here's where search is. Here's where graph is. That way, the services themselves, they don't have to talk to each other. They just talk to XCD, they find out where they need to go, and anyone who actually needs to talk to the cluster can. The generator is the service that's going to generate all the fun data, and we'll start the app up. So by the way, I'm only right here, I am just telling my app to talk to Docker, and then from there, it's talking etcd, and you see it grabbed the cluster information. It got that. There are the services here that all just started up, and now it should start doing stuff. And if it did, if I go to localhost 3000, I should have videos. Yay! Okay, cool. So it's, you can see here, yeah, the generator is doing its thing. So when you see this stuff going, that's just all, it's just the log output where as videos are being added into the system, comments, rates, all that kind of deal, that's happening. So a couple things going on from the app standpoint, right? So this is now running on Cassandra. No. Now we had a fire alarm. I was like, oh no! Yeah, this is running on. It is DataStax Enterprise, but it's the Cassandra core. And then, as I mentioned, we have both search and graph. So I just want to point out some of those areas there. So right here on any of the videos, if I click on any one of these, you'll actually dig into the video. You'll get, as I mentioned before, the ratings, the comments. You'll get them various sections, like the more videos like this and everything. This search type ahead is actually based off of DSC search. And just like you would expect for a type ahead, right? If I go ahead and I start typing things in, whatever I type in, that kind of deal, you'll see I start to get a list of things. And actually these lists are much larger than what I'm showing. I purposely limit the amount of results because some of them would come back and, you know, they'd go down the page and everything, so I don't do that. So I think you get the idea. But that is search underneath the hood. Now, does it have to be? No, it honestly doesn't have to be. When we originally built this, we did not have DSC search integration in place, and you could totally do that with Cassandra. The reason why we went to search is because we wanted to start extending out the capabilities. So with Solar and Lucene underneath the hood, right? You have full document search capabilities, you have full Lucene capabilities. So if you're familiar with those technologies and what they can do for you, then that's where search really comes into play. So when you're actually typing in the type ahead there, you're actually searching across a bunch of different data. You can do wildcarding, you can do proximity searches, all sorts of things. Let's pick a video, because I did mention there would be cat videos. Then there is the tag search. Tag, again, originally was implemented where it was just a videos by tag table. That's all it was, right? It was real simple. But again, we wanted to extend this out to make it more comprehensive. So if I click on one of those, then now I'm going to look at like Grumpy Cat videos. I could do that with whatever really, yeah, Azure, right? I think you get the idea from that standpoint. Let's pick another one. And then this last one, this more videos like this, right? Notice that I don't have any tags. There's no tags there. So what's happening is we're actually parsing the information out of the name description. We're parsing terms out of that, and we're actually passing that to the search engine as well. What's really neat, though, from the search standpoint is, if you've ever come from the OSS, Solar, and Lucene world, they're extremely powerful tools. But then when you're doing it from open source, you have to manage your own cluster. You have to learn how to parse results out. You have to synchronize the data between your system of record and your indexes and such. From the DSC standpoint, when you enable it, that happens for you, right? And we're actually going to show you a notebook here in a second. We're going to go through some of that, and you'll get the idea there. All right, so from the app standpoint, the last piece is the graph part. So you see this recommended for you. This is where the graph recommendation engine comes into play. Now there's nothing there because I haven't liked anything. So in this particular case, what we're going to do is, to get recommendations, I want the recommendations of other users who really like the same types of videos that I really like, right? This is where you start to see these nested relationships come into play. So let's just pick some. I usually try to game it, honestly, and find one that has more views. Let's see, we'll just pick this. I'll rate this one. Not yet. Pick this one, why not? Yeah, so I'm looking for ones that already, see, it didn't have, if nobody's rated it, it's not going to matter, right? So that's where I'm looking for one that has there. Let's do Key and Peele. Let's see, it's got to have some ratings, right? All right, there's some ratings. There we go. Maybe I get one. Oh, this is just going to make it. There we go. Yeah, all right, cool. So now, great. It showed some videos. Let's look at actually what's going on underneath the hood. So one of the other things that you get with the test drive is this link to Studio. So we had the piece with Op Center in there, but then I also give you Studio. So this just comes with the test drive. Studio, by the way, it's a development tool. It's a notebook, like if you're used to like a Jupyter notebook or something, it's just like that. And it allows you to hook up to your DataStax Enterprise cluster, and you can execute CQL, gremlin traversals, Spark SQL, Markdown, all sorts of things. And what's neat is the default notebook comes with notebooks like you see here, that you can just launch these. And if you're really, from a learning perspective, if you're trying to figure out, well, how do I do this stuff? It's great because you can start like the working with CQL one. You can go, well, how do I create a key space? There it is, and it gives you instructions. What does a data model look like, right? How do I do that? You know, it'll break it down for you, and it's already there. You don't have to do anything; it's just there. All right. So what I'm going to do is I'm going to grab the notebook that I created for you guys. Now, in the meetup page itself, we included both the slides but the notebook as well. So if you guys are interested in that, you can grab the notebook. And one of my favorite new features is the fact that you can just drag and drop those in there. You can just import and export. And now this is the notebook that I created earlier for what we're doing today. All right, so what I want to do is cheat a little bit. All right, so I'm going to talk while I do this. So Killer Video, when it bootstraps, it creates a set of indexes that it needs for what it's doing. But for our particular case here, I'm going to do a couple extra things. I'm going to change some of the indexes. Part of what I want to illustrate, though, while we're doing this, is the fact that from a Solar standpoint, I can actually create and alter my indexes on the fly, and it will automatically handle all the synchronization of data and all that for me. So that's actually what I'm doing right now, right? So since I wanted to change this a little bit, I created an index here in Killer Video Users. We're going to use that in a second. And then I dropped the existing one that was bootstrapped as part of the app, and I added a new one. But here's really what I'm after. So by default, when you create an index on a text field, it will use a string field, which is case sensitive. It's meant to be very efficient. It's quick. It doesn't have full text search capabilities. So if you want that kind of thing, you can just add, and that's what I'm doing here. I'm adding a text field. I'm giving it like a lowercase ability, and you can just add that to the index on the fly. So I'm actually saying, all right, I want this new type of field that's going to be called text field here, and then I can just apply it to existing indexes. And when I change that schema, I haven't actually, right now I've just put this in pending status, but what's going to happen is this reload search that's going to allow me to change that into an active status, so that will put it into production, if you will. And then the rebuild, that's the part that just synchronized the data. So if I had a previous schema out there, I was already using indexes. When I made this change, by the time that's done, all of my data is already loaded into the new indexes with the new changes. Yeah.
In your code there, you had tokenize. Are you actually tokenizing your data as you're going across?
Yeah, so that's a really neat question. Are you asking, are we tokenizing data across the nodes?
Right.
The data, when you choose the text field type, the data is going to be, I believe it's going to be tokenized locally on that node. Okay. Right, because I'm actually glad you asked that, because something I hadn't really clarified is that Cassandra is always the system of record, right? Cassandra is the core that all of the stuff that I'm talking about is on. So when you are building these indexes, that index set is going to be local to each node, right? So when I did that, I actually did that across my whole cluster. Every node that I had search enabled on, that I connected to, that all just re-indexed and tokenized locally on each node. Does that make sense? Okay. All right, so here, I just want to go through just some examples, right? So one in particular, I have this user, David Gilardi, that I created when I first logged into the system and everything. And there's something, without going into a data modeling course, there are some pieces when it comes to core Cassandra and how you actually query, right? It's a little bit different from SQL, right? The CQL language and the database itself, the capabilities that you have with Cassandra are a little bit different. And it offers some constraints, right? There's examples of, say, doing certain types of range queries, or depending on how you build your primary key, right, and the ordering of your clustering columns. Once you have that in place, you don't change that at runtime. So there are reasons, there's really good reasons why that is that way. It has everything to do with how you've got extremely fast reads and writes and such, but it can be a limitation. There are some people that's frustrating, and this is where search actually helps out, because when you start enabling search and you start creating your indexes and columns, now you can start to use an SQL-like syntax where you can execute queries that look just like SQL, and you can do all the types of things you would expect with that. So let's take the next one as a good example. That's right. Yeah, so notice that I've got a range here. I can change my ordering if I want to, like no problem, right? That's not an issue. If I were to try to do this in just straight up Cassandra, it wouldn't let me, right? It would yell at me. It would say, no, you can't do that. But once you have the search piece enabled, and once you enable indexes, then you can start doing that. And if you notice, the syntax looks every bit like SQL. That's the point. There was actually something new that we added pretty recently. Let's look at some cat videos. Now the contains keyword is key, because if we take a look at our videos table here and we look at the tags column, that's actually a collection, right? So you can store collections of data inside of Cassandra. So you can use the contains keyword with search in order to search through those collections. You can see I've got the collections here, cat and funny, right? And I'm just looking for cat. Again, looking very SQL-like. Another thing from the search standpoint is going to be counting, and I'll say reliable counting. If anyone, I know I've got a couple Cassandra users. I'm gonna totally pick on one person. If you ever tried to do counts in Cassandra, do you know about the fun of doing counts in Cassandra? Yeah. So what it comes down to is when you do something like a count in Cassandra, you effectively are forcing a scan, a full scan across all of your nodes. You don't want to do that. It's a total anti-pattern, right? Not only that, with the way that data is stored in Cassandra, counts generally are not reliable. You would not, from a core Cassandra standpoint, I would not want to actually do a count if I wanted to get a reliable result. And there's reasons for why that is, but with search, you don't have that issue anymore. Right, so when you have search enabled, you can actually do the same thing with bulk loader. Bulk loader is actually a really good way to handle doing counts. But with search in particular, right, you can then augment that capability, and then from the search standpoint, you get good reliable counts, and you're not doing full table scans. This is the big thing, is that again, when you have a distributed database, especially in the case of Cassandra, the whole point of having it is you don't want to be causing a scan across. In a matter of fact, if you were to try to do certain types of queries, if you're doing them in pure Cassandra, it'll yell at you. It'll tell you, hey, you're going to cause a full scan. You may want to enable allow filtering, which we would say, yeah, don't do that, right? So again, this is where you can use search in the DataStax Enterprise standpoint, and you can just use that to help augment some of this. And then now this should look really familiar, doing like with wildcards. We've been doing this SQL for decades. But this is a case where the name column actually has a search index, and because I have that, I can get the full text search capabilities. Now, I mentioned before Lucene syntax, right? So you may need to do something that's a little more complex or complicated than the basic search syntax you'll get in the SQL-like syntax. And that's where Lucene comes into play. So if you just write your query and you add the pseudo column called solar query, and you can see the Lucene syntax there, I can now start doing wildcarding. I can put term weights on, pretty much anything you can do in the Lucene syntax you can do here. So it allows you for a lot more complex and more interesting searches. And it's the same thing as we go down here. This is actually an example of something I pulled from doing the more videos like this piece, where you can say I parsed out these words from the name, description, and everything, and then I'm actually searching across. There we go. I'm actually searching across name, description, and tags to get those. So the only real difference is the fact that I'm using the Lucene syntax here. What's neat though, where this really comes into play, is that from a code standpoint, we're actually talking when you're coding the application, the code that I need to execute within my application to do both Cassandra or search queries is identical. right? So the types of results I get back, it's identical. I don't have to do any weird parsing. I don't have to work with different drivers or anything like that. Matter of fact, if you notice, it's the same SQL syntax and everything. The only difference is I've got this special little pseudo column in here. All right, so I'm just going to go on to the graph piece. And a graph gets fun. So the first thing I'm going to do is something I don't recommend that you do unless you're only in development. Hence why you see the special modes up there. So with graph, graph is really interesting. You can graph is extremely powerful, but like anybody who's worked in Unix for a long time, it lets you do anything, but you can also totally clobber yourself, right? And with graph databases, you know, if you write a traversal that's recursive and you don't put limits on it, or you don't understand maybe what's going on there, you can run into some interesting response times. So what this is allowing us to do is normally the engine will automatically limit you, right? It'll tell you, hey, you can't do this. You need to have an index here to do this. I've turned that off. So that cell, that's all that's doing. It's just putting it in development mode. This is good for, let's say I'm just testing out a new traversal. I haven't really worked out the details yet of what I'm doing. I'll turn this on to work it out, and then I may go back later and I'll find out how to index properly and everything. So I just wanted to point that out because I want to make sure that people don't grab those for fun. So here, what I'm actually going to do is this is actually grabbing the graph real time. Now I'm doing a sampling right now, just to give you an idea that I said sample 1,000. I'm just saying I want to sample from 1,000 of the vertices that are around. You could have these distributed graphs will support millions, billions of edges. I mean, you can have an immense amount of data. So obviously, if I try to return all of those, I'm going to have a real hard time displaying that. So I'm just telling it to sample. Now, one other thing to notice though is that these labels aren't very useful. So one of the things that Studio does is it allows you to change those, uses mustard notation. So what I'm doing, oops, I have my caps lock on. So what's actually happening here is for each of the vertices that I have in place, that's email, there are properties. So let me just finish this real quick. There we go. Yeah, I have a question.
A quick question coming in from online.
Yeah.
It says, in Cassandra, can I run table scan confined to a particular node or replica?
You could create a query that had a partition range that was on a particular node. I guess my follow-up question to that though is, if you can do that, why would you want to? What are you trying to do that you'd actually want to run a table scan, to a certain node? Like, what are you trying to get at? Because there may be other ways that you can get at that kind of information. Okay. So notice then now you see more useful names. Now this. Right now, we're not doing anything special with graph, right? You just get all this information. This is just to give you an idea of what that graph looks like as it's emerging, but it's not really useful yet, right? All right, so let's take a look now. In one of the other things that Studio allows you to do is you can set variables that then the rest of your cells can use. So instead of trying to and having to set these every single time, I get to set them once, and all of my cells will use them. So they're just properties that I'm using here. All right, so I mentioned that recommendation engine before. So here's what we want to do. You saw me rate about 3 videos. As a matter of fact, why don't we go ahead and rate one more for fun, because I want you to see that real time. So what's happening in the app is, we'll just pick on this one, it doesn't matter. When I rate the video, right, that data is being stored in Cassandra, but then it's also asynchronously being written to the graph. Now, Cassandra is still the system of record. So it's all part of the DataStax Enterprise stack. It's all there, but I am in the code. I'm actually asynchronously writing that to my graph. And so when I come back over to Studio and I run this again, we should see a 4th one pop up, and there we go, right? So my graph is being populated, and you'll start to see some of these relationships emerge as users are doing things in the system. Now, another thing you can do here from a Studio standpoint, you can actually change the icons for vertices, make them a little bit more descriptive so you can get a better visual of what's going on. And so I'm just going to change some of these here. There we go. Okay, good. Okay, now we can see, this is that user, David Gilardi. This is the one that I created and that I've highly rated right? So my rating scale is 1 to 5, and highly rated to us is 4 to 5. That's what we're using in our traversals. And so each of these should have at least 4 to 5. So all I'm showing here is the first step. Okay, so I've got the relationship from the user to the videos that I've highly rated. Now we'll go down to the next guy. So what I want to show in this next spot is I want to start finding other users who highly rated the same video. So we see we have one here. So I highly rated this Macedonian Cafe one, and somebody else did, right? Now for the recommendation engine to do its thing, I want to find what videos they highly rated, right? And so I'm going to do that in this next one. Come down, and you can see I had results from before, but these are the ones that are live now. Okay, so now what's happened is, again, this is that Macedonian Cafe, right? And now I've got this other user, and they highly rated a bunch of other videos. So what's happened is, from the recommendation engine standpoint, when you saw that real simple display on the front page of the app, and it said recommended, videos, what it was doing is it was looking to all of the other users that highly rated those same videos, and then it's getting the pool to select from, really, the videos that they highly rated. And these are the ones I want in the recommendation engine, right? So it's just we're just using this to very easily kind of step through the relationships and how you might kind of look at those or how they emerge in the graph. And this is a really simple case. We see some use cases where people, especially if you look in the fraud detection world, I mean, killer video doesn't have anything to do with fraud detection, but if you look at some of the use cases, you can get into some extremely interesting and useful models with how people are using the relationships, especially with relationships to disparate data, to tell you if, hey, you're here in Philadelphia, but I just saw someone make some purchases over in Texas, and so on and so forth. So that's one of the areas that graph databases really get into play, and I just wanted to illustrate that here. And then finally, this is the actual, now, one thing I'm totally glossing over, because if you're not familiar with graph databases, here, there are traversals in here, right? So this is the gremlin language. I'm purposely glossing over that unless anyone wants to really look at them, because depending on what you're doing in some of the traversals, they can start to get a little bit more interesting, right? But there is something under here. It's not just a picture with it. There's actual gremlin traversals. And again, from a code standpoint, that's where this matters, right? You can write that same traversal that you see there. You can write with the Fluent API right in the driver. You can just write that. And you could take that exact traversal and you can just put that in your code. And again, just like you do with Cassandra and with search, you'll get those results back out in the same exact way, right? So that whether I'm using rows and columns or if I'm using a mapper or whatever, you'll get them the same way. So from an app dev standpoint, that really helps.
His follow-up to your question, because there's a bit of a lag here.
Yeah.
He said, say if a subsection of data is confined to a particular replica due to business reasons and they don't want end users from a particular geographical location to view the other location's data.
So, right, there are a couple different ways you could handle that particular case. I would say one, though, if you did have a geographical location and that was the thing that you were looking at as a differentiator, you could probably partition by that. And that way you're going to, just by the nature of how Cassandra is going to store data in partitions, then when you execute the query, and if that's your partition ID, or if you use something like that, you can just put that in your where clause with that particular geographical location, and it will access only that partition, right, and the information within that partition. So if you were looking, maybe you were separated by Texas over here, and you had, Illinois and the other one, you could set your data model up where it would just pull the sets that you need. As far as, well, I wanted to read from one replica or another replica. That's kind of interesting, because when you are setting your replication factor, right, you are telling the cluster that I want that data replicated across multiple replicas, and that's part of what gives you the power of being distributed. So I don't know, and Steve, I don't know if you know off the top of your head, I don't know, it wouldn't be so much limiting it to a specific replica, but it would limit it to that partition, and that could go to any of the replicas where that data is, right? So there are ways through your data model that you can handle it. So it depends on the use case. Yeah. Is there another one, or is that? Okay. All right, yeah, so just the last thing here to start wrapping up is this is the actual, don't get scared, Yeah, no. That's the actual traversal for the recommendation engine. It's not too bad. We're not going to go into detail of how that actually works. I just want to show you it's actually a real thing. So if I look at the videos here, maybe cute is not enough. Whoops, and we come back up to the front. We'll see that I have cute is not enough this week in Cassandra. No, wrong one. Yeah, cute is not enough this week in Cassandra, right? So that is the actual recommendation engine that's deployed there. Okay. Oh yeah, we have a question?
Okay, so the follow-up to that.
Yeah.
So that scenario can also be handled by the way we model the data by understanding how the partitions work, etc. But there's no other option to see that you can restrict it to a particular.
Yeah, so I don't have, as far as being able to say, I want to perform the query only against this one replica. That I don't have a good answer for, and the reason why is if I'm replicating my data out to multiple replicas, right? Then when you execute the query, you could potentially go to any one of those replicas that has the data, because they all have replicas of the data, right? Now there are ways if you're looking to just get a certain set of data, and it came down from the original question about doing a full scan. To me, I guess I'm shying away from ever doing a full scan. Because it's an anti-pattern. You don't want to do that. There are other ways. You could use a search index to do that, right? But again, are you specifying to just one replica? I don't know of a. I'm not saying that it's not doable. I don't know of a way that I could just say, no, you talk that. The only way you could potentially do it is maybe you CQLSH into that one. but even at that, like again, you're in a clustered environment, so when you execute that query, if you have multiple replicas, then you could potentially be going to any of those where the token range fits, or where your partition key fits. Does that make sense? Yeah. 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 Well, if you partition it in such a way, I mean, you could set in the same replica. It could. It depends on the token ranges of the nodes, right? So if it used to be in times past, you actually had to set the token ranges, right? And then when your key gets hashed out, it would go to those particular ranges. Now there's vnodes and it'll automatically manage that for you. But you're right, you could have multiple partitions, right? You could have Texas and Illinois in the same one. So it just depends on where that gets hashed out and where it's stored on what node. Mm-hmm. Yeah, how are we doing on time?
You have 4
minutes.
yeah. And there
yeah, go for it.
Go ahead.
Okay.
Give me one more.
Spark, they have like predictive style for taking advantage of the Cassandra's right?
Mm-hmm.
So we have the piece of designing the application. What would be the predictive style? So the prediction can it be done only on the partitioning and the cluster column, or can it be done on any column with color style?
Yeah, so you can combine, this is actually a really neat question, because you can combine, Spark will do that on its own, right? And that is actually, when you're talking about the Spark integration with Cassandra with DSE, that will actually handle that for you across your nodes, but you can add in search indexes. And if you have search indexes on those nodes and you have that workload on, then Spark will automatically use the indexes for any of the columns where those exist, right? So it will handle that for you across your nodes, depending on how you construct your query, whether or not you have search. But if you have search in place, then you can do that a lot more performant. Yes. Yeah, as a matter of fact, if you were using columns that are outside of your primary key, so either your partition or your clustering columns, that's one of the things you can do with Spark. You can actually write, funny enough, I don't have it here because I don't have it enabled, but you can write queries with joins that look like the SQL kind of like syntax that we've known and loved for a long time, and that will handle that for you. So Spark will do that.
Following up from the previous set of questions around that, the question is, does local _ quorum settings help?
Yes. Yeah. Thank you. That's a great question. So Steve talked about this a little bit when he had multiple data centers, right? So there are consistency levels. We haven't really talked about those, but in the distributed database standpoint, this question comes up all the time. So you've got this replication factor, and you have, let's say in the example Steve gave, he had 4 nodes and he had a replication factor of 3, right? Well, there are different consistency levels I can use with that, and I can do that in my app. I can do that at the query. You have what we call strong consistency, where you might use a consistency level of all. Where just by the name, I think you could probably understand what that's doing, right? It's going to say, okay, when I perform this write or this read, I'm going to get acknowledgement back from all of my replicas. Now, we don't recommend that just because it's not very efficient. There's quorum, which is majority rules, right? So if I had three replicas, then say 2, right? I want 2. Almost more fingers came up, but it would want 2. So when I would write something, it would wait for acknowledgements to come back from, say, 2 of those nodes instead of 3. Now, in the local question, right, if I have a single data center, that part doesn't really matter. But if I have multiple data centers, right, this is where local comes into play. So for those consistency levels, I have 1, quorum, things like that. We also have local 1 and local quorum. What that is saying is, I want you to apply that consistency level only to my local data center. Because if you think about a case, let's say you have geographically dispersed data centers. Maybe I have one in the East Coast and one on the West Coast, and my application is here on the East Coast. I don't want to perform those queries or those writes or mutations on the other one, right? I've got a speed of light issue going on. So I can tell it local quorum, local 1, and it will make sure the consistency is working against just that particular data center. So generally speaking, I would suggest to always use the local versions, even if you have a single data center, because the second your application extends or your cluster extends to having multiple data centers, you're set, right? You're all good. Yeah, so the way that'll work, that's actually, if we go back real quick to the, right here, 1 minute, okay. Yeah, if we go back right here to how we're setting our replication settings at the key space, if I had multiple data centers, you see where it says DC0, let's say it was DC1, I could have that as well. What will happen is anytime there's any mutations that are being performed, it will automatically replicate that. And then it will do it to both data centers. The consistency level has nothing to do with that, right? So regardless of what you're using for your consistency level, the replication factor always applies. So yeah, if you've got your data center set up in that way, then you'll automatically natively replicate. Okay, all right, then I will just close with this. You guys want to, if you ever want to reach out, I'm on Twitter, Sonic DMG, LinkedIn, whatever. I have a blog. I don't update it often enough, but I have one. So thank you guys. Cut them off.